Lesson 5.4 is about modeling data with a curve of best fit. So in example 1, we have a physics class that is measuring the height of a bouncing ball. So they're giving us 3 trials, trial 1, 2, and 3. The time is going to be labeled as your L1, which is your independent variable, and your heights are going to be L2. And what you'll need to remember is that these charts will continue on in the same L1s and L2. So you're going to write all these times. Even though they're repeated, all of them are going to go into L1. So trial 1, 2, and 3, and then you're going to repeat the heights for L2 for trial 1, 2, and 3. So we need to decide which variable is the independent variable. So time is our independent variable. So the shape of this, if you look, a bouncing ball will do something like this. So this is actually going to be modeled by a quadratic polynomial. So a quadratic function is what the curve will actually look like. The domain will be representing the smallest time, which we know is going to be represented by 0. So time of 0 is the smallest time we have, up to a time of 1 second. XER, because we can have decimal values in between them. And then our range, we're going to have to look at the y value. Our smallest height is 0 up to the highest height seems to be 2.53 YER. What type of function does the curve represent? Well, we can say that this is a parabola shape, and because a bouncing ball will go up to a maximum height and then down to the ground and hit the ground. So determine the equation of the function to model this to the nearest hundredth. This is where we're going to have to enter all these L1s, L2s into our chart. So step 1, you're going to have to go to your graphing calculator. You're going to have to press second plus sign number 4, enter. So that's where you clear your lists, and I explained that in the previous lesson. So you want to go second plus sign number 4, enter. Once you've cleared your list, you want to go to stat, edit, which is number 1, and you're going to enter all the L1 values. As you can see, I repeated and did trial 1, trial 2, trial 3, all into L1. Then I did the heights of trial 1, trial 2, trial 3, all into L2. Once you've completed that, you're going to press stat, go to the right till you've highlighted calc, and you guys are going to, in your calculators, you're going to select number 5. So you guys are selecting number 5, which will be quadratic regression. So it should say at the very top, quad regression, and you're going to press enter until it calculates something like this. So this is our quadratic equation that we need to label as, in the form, it's going to be y equals ax squared plus bx plus c. So you're going to have to replace your a value with negative 9.79, x squared stays as it is, plus 10.01x, so that's your b value, if you guys look. And your c value, you're going to have to be very careful because this is scientific notation. So you're going to have to put 7.14 times 10 to the power of negative 4. So if you see in my equation, it says 7.14 times e to the negative 4. You need to include that as your constant. So this is the equation to the nearest hundredth that models the data. Our next question is asking us to find the vertex to the nearest hundredth. So this is where I'm going to graph it and then find out the maximum. The vertex in this case, if it's downward facing like this is going to be called a maximum value. If it's upward facing, it's going to be called a minimum value. So what I'm going to do next is I'm going to go to y equals, I'm going to press vars, then you're going to select statistics, which is number 5 for you guys. You're going to go to the right until you get to equation, and then you're going to select 1 for regression equation. That's going to copy and paste all that data in for you so that you don't have to rewrite it. Then you're going to go window, and you're going to enter that our smallest time was 0, up to our highest time was 1 second. Our scale, I would change it to be smaller, maybe 0.01, because since our values are going from 0 to 1 for min to max, we want the scale to be smaller than that to divide it up. Our Y minimum is going to go from 0 up to a maximum height we know is 2.53, so I'm going to go slightly higher up to the value of 3 and then graph it. Okay, so it should be graphing it for me, which it's not for some reason. So let's see if I can retry this. So vars, number 2 statistics for me, for you it's number 5, regression equation. Then my window, I know it's going from 0 to 1, so that's still not changing for my x. And then I'm going to graph that guy. Okay, so I'm going to switch to Desmos because for some reason mine is not doing anything there. And I'm going to re-enter those values that we have written out in here. So mine's going to be slightly off because I am going to have to round these values. Okay, so if you guys look, there's my graph now drawn out. Now, if you use your calculator and use the window that I provided, it will come up. It's just my calculator is not graphing it for me. So once you have that done, in your calculator, you're going to have to, once it's graphed, you're going to have to press second trace number 4. So I'm going to write down these steps for you so you guys can refer to them. So to find your vertex, you're going to have to graph it, and it looks like this. You're going to have to press second trace number 4, which is maximum. You're going to have to press enter. And what that's going to do is it's going to say what is the left bound, the left side of it. So you're going to move your cursor about here on your graph and press enter. Then for the right bound, you're going to have to move your cursor about here. So this is the right bound, this is the left bound. Move your cursor approximately there and press enter again, and then enter. And you should get that the vertex is about 0.51, 2.56. So I'll just check that. As you can see, mine's going to be a little off because it is it's just rounded, but as you can see, it's to the nearest hundredth that I'm rounding it to. So that's the vertex, and that is what I want to do for that guy. Okay, so yours will show up if you use the window that I provided you. So remember, the window I used was going from 0 to 1, going up by a scale of 0.01. And then for your Y values, you're going from 0 to 3, going up by 1. So that will show you the graph, and then you just want to go second trace number 4 for maximum. Go to the left side of that maximum, the right side of the maximum, and press enter until you get this for your vertex. So these are the coordinates of your vertex. So your vertex is just that highest point. Example number 2, you're going to graph the years into L1, and it'll continue here into L1, and then your price of gas will go into L2 and then L2. So they want the polynomial function that's going to model this data. So if you guys were to sketch this, this will actually look like a cubic function. Now, there's a button in your calculator that can help you actually prove that. So I'm going to show you that if you press second 0, that's going to take you to the catalog. And then what you can do is if you scroll down, and it sometimes takes a while, you're scrolling down to the letter D, and you want to find something that says diagnostic on. So once you have diagnostic on, you're going to press enter, and then you're going to press it again. So you're going to press enter twice. Once you have done that, it will say done. And what that does is it turns on this this kind of button that tells you how accurate your graph is. Because in this example number 2, it doesn't tell you if you're using a quadratic or if you're using a cubic function. So a cubic function is when it's x to the power of 3 versus a quadratic is x to the power of 2. So it doesn't tell you that. So if you now enter all these data values, you can then try number 4, which is try number, actually, I believe it's number 5 for you guys for quadratic. So you have a choice between number 5 in the calculator when you go to calc, or number 6, which is cubic. Now, if you press those buttons now, you're going to get this R value. So that was actually visible when I did mine. So the R value, if I go to stat and then calculate it, and let's say I'm doing a quadratic and I calculate the values. Well, it gives me this R value, and this R squared value tells you how accurate your graph is. So if you see something like 0.9985, well, this is a 99.85% accuracy on how good this graph is. So you want to pick the R value that is the highest between the two. So if you pick the quadratic or the cubic one, you want to pick the one that has the highest R value. So anything that's closest to 1 will be better. And if you actually do that, that's going to work out for the cubic one to be the best. So cubic will actually be the best for this graph. Once you know that it's cubic, you're going to enter all these values into L1, L2, like we said. Then you're going to go to stat in this case. So you're going to do the previous steps that we did before. You're going to go to the arrow. Once you press stat to calc, and then you're going to go to, in this case, number 6, which is a cubic regression. And you're going to press enter. So once you've pressed enter, you're going to keep pressing enter until it calculates it for you, and then it should give you an equation that looks like this. So you know you've done and entered these values properly if you get approximately these values, this value for A, 0.01, minus 0.46 for B, 6.30 for C, and your D value should be about 23.45. Okay, so now you're going to estimate the price of gas in 1984. So we need to figure out how many years after 1979 this is. So if you go 1984 subtract 1979, you're going to find that that's 5 years. So 5 years have passed since there. So to do this, you're going to graph it by pressing y equals. Then you're going to do the vars button, number 5 for statistics, once you've pressed 5, go to equation at the top and then press number 1. So what that does is it copies and pastes that equation that we got for B into the y equals. Then you're going to change your window for x to go from 0 to 30. So that's going to be years after 1970, going up by 1. And for y, your y minimum, you can set from 20 to 120, going up by 1. Once you graph this, you're going to have to go trace X, you're going to enter 5 and then press enter. And if you do this properly, you should get that the Y value is about 44.85. So that's the amount of cents. So it's going to be approximately 44.85 cents per liter. Cents per liter. Now they want to know, when will the average price be 56 cents per liter? Well, this is a Y2 value. So remember, our Y1 was that cubic equation that we should already have there. But then Y2, we're going to put 56 into Y2. And so when we graph it, we can keep the same values, the same window here. So once we graph it, we should see an intersection, and then you're going to press second trace number 5. And when you press enter 3 times, that should give you an intersection of about 16.47. So that's about 16 years after 1979. So we can go 1979 plus 16 years, which is 1995. Okay, so that would be approximately the year that the gas price was 56 cents per liter, or it can even be 1996 if you had rounded to 16 years. Okay, so that is how you find your answer. So that is your lesson.